Have you ever looked up at the cerulean expanse overhead and wondered, why is the sky blue? It's a question that, upon first glance, seems deceptively simple. Yet, nestled within this everyday observation lies a rich tapestry of scientific wonder that can not only illuminate our understanding of light and atmosphere but also evoke a sense of awe about the natural world. Stay with us, because in the next few moments, we'll unravel the science behind this mesmerizing hue and explore some surprising truths and intriguing facts that you never expected. As children, many of us were taught that the sky is blue, and while that's certainly true, the intricate reasons behind this phenomenon often elude us. You might be wondering, is it merely a trick of light or something more complex? The truth is, the blue of the sky is intricately tied to the way sunlight interacts with the Earth's atmosphere, a dance of particles and wavelengths we're only beginning to fully appreciate. To start, let's delve into the very essence of light itself. Sunlight, or solar radiation, might appear white to the naked eye, but it's composed of a spectrum of colors: red, orange, yellow, green, blue, indigo, and violet. Each of these colors corresponds to a different wavelength of light, with red lights boasting the longest wavelengths and violet lights the shortest. You might be surprised to learn that these wavelengths play a crucial role in determining how we perceive color in the sky. Now, as sunlight passes through our atmosphere, it encounters myriad particles, oxygen and nitrogen molecules, dust, and water vapor, to name a few. This interaction brings us to a pivotal player in our story, Rayleigh scattering. Here's something you didn't expect. Rayleigh scattering is why the sky can appear in a range of colors, from deep blues to the soft pastels of dawn and dusk. When sunlight meets these particles, shorter wavelengths of light, blues and violets, are scattered in all directions far more than the long wavelengths, reds and yellows. But wait! You might be puzzled here. If violet light scatters even more than blue, then why isn't the sky a grand shade of purple? Great question. The reality is that our eyes are more sensitive to blue light than violet. Furthermore, some of the violet light is absorbed by the ozone layer, making blue the most prominent color we perceive in our daytime sky. Isn't it captivating how our sensory perception shaped the world around us? Just when you think you've grasped the entire picture, let's add a twist. Have you ever noticed that the sky changes color at various times of the day? The golden hues of sunrise and sunset create stunning oranges and reds, while noon typically offers a brighter blue. This change is a direct result of the sun's position in the sky. At noon, when the sun is directly overhead, sunlight travels through less atmosphere, scattering minimal blue light. But as the sun begins to set or rise, its light must journey through a larger expanse of air, scattering the shorter wavelengths like blue and violet even more, allowing the longer wavelengths, reds and oranges, to dominate our horizon. Here's a thought to consider: what if the sky could change with our emotions? Imagine a world where our feelings painted the atmosphere. Would that reflect the energy of our thoughts? While this remains a dream for now, the way our skies interact with human emotion is compelling. Many people find comfort in the blue vastness above, a calming and soothing backdrop that contrasts sharply with the chaos of our daily lives. There's even a psychological effect linked to blue that suggests it can promote feelings of tranquility and peace. You might be wondering if all skies around the world have the same blue. The answer, of course, is no. Atmospheric conditions vary widely across the globe. In places with high pollution, for example, the scattering may lead to a grayish or hazy sky, while high-altitude locations provide some of the most vibrant blues. This variability is a reminder of how our environment shapes our experiences and perceptions. Think about it. Have you ever stood atop a mountain during a clear day? That deep azure blanket above is breathtaking and serves as a testament to clear air and uninterrupted sunlight. Now let's journey a little deeper. What happens when atmospheric conditions change? Did you know that a stormy sky can exhibit beautiful shades of gray and navy? Clouds form when moist air rises and cools, causing water vapor to condense. This process transforms the atmosphere and its interaction with light, leading to these stunning transitions. In fact, sometimes those clouds may scatter blue light differently, creating moody effects that can feel both foreboding and awe-inspiring. As we venture further into this exploration, have you ever pondered why we see colors in the sky other than blue? In certain regions, particularly near oceans or in landscapes with unique geological features, the sky may take on various shades ranging from turquoise to deep indigo. This isn't all due to Rayleigh scattering, but also refraction, reflection, and the presence of water bodies that can affect light conditions. It's a delightful reminder of the multifaceted world we inhabit and prompts the question, how much influence does our environment exert on our perception? Let's take a moment to explore the phenomenon of sun dogs or parhelia. These captivating optical phenomena occur when sunlight is refracted through ice crystals in the atmosphere, creating bright spots on either side of the sun. Many people may not realize this, but these colorful spots can appear even when conditions are chilly. It's extraordinary how tiny ice crystals can transform our view, creating halos and colored arcs that can leave us speechless. It's moments like these when the science of the sky merges harmoniously with the art that transcends our everyday experiences. Now consider this, while we marvel at the blue sky overhead, what lies beyond our atmosphere? As we gaze up, we might forget that Earth's atmosphere is just a mere veneer surrounding our planet. Beyond it, the vastness of space presents a black canvas dotted with celestial bodies. Without Earth's atmospheric light scattering, the vast majority of our sky would be pitch black, deepening our connection to the universe. As our journey continues, let's address the question of why our planets and moons appear with varying tints as well. Mars, known as the red planet, displays a reddish appearance due to iron oxide, or rust, on its surface. Then, there's Venus, which is renowned for its thick, cloud-covered atmosphere that reflects sunlight, giving it a bright and soft yellow glow. Each celestial body offers its own unique palette, demonstrating how different atmospheric compositions can alter our perceptions of color throughout the universe. What comes next will leave you speechless as we unearth not only the science behind why the sky is blue but delve deeper into cosmic wonders. Have you ever experienced a rainbow? This phenomenon is another beautiful interplay of sunlight and atmospheric conditions, resulting from the refraction, dispersion, and reflection of light in water droplets. When rain and sunshine coincide perfectly, a breathtaking spectrum emerges. To think that the very same sunlight that scatters to gift us our blue sky can also paint arcs of color is purely mesmerizing. As we come to a close, we must return to our initial inquiry: why is the sky blue? The answer, while multifaceted, reveals a profound truth about our connection to the world around us. The blue sky is not merely a backdrop, it's a story of light, perspective, and the delicate balance of our atmosphere. So, the next time you find yourself gazing upwards, take a moment to appreciate this awe-inspiring view that encapsulates the intricate science behind color and natural beauty. Our planet is a marvel of interconnectedness where science and art converge, leaving us curious, enchanted, and eager to explore even more mysteries that the sky has to offer. As we wrap up our exploration of why the sky is blue, remember that this simple question encompasses a world of science interlaced with wonder. The next time you see that brilliant blue overhead, let it remind you of the dance of particles, wavelengths, and perspectives that shape our experience of reality. The sky, with its endless shades and moods, invites us to look higher, think deeper, and grasp the complexities of the world we inhabit. Our curiosity about even the simplest phenomena can lead us to profound revelations, beckoning us to continue exploring, questioning, and engaging with the beauty of the universe. Isn't that, after all, the true essence of discovery?